Welcome to the demonstration movie of the latest product from FARO Technologies called FARO Reality. This is a full-time three-dimensional product that allows you to draw, model, simulate, animate, and do very advanced reconstruction calculations. In addition, this product has the benefit of being able to use its 64-bit architecture to download billions of points and create a dense point cloud scene that can also be used as any other scene. So what we're going to do now is demonstrate how it works. We'll start off with the simplest part of the program, drawing. The drawing engine within FARO Reality is capable of the same level of drawing as any other sophisticated CAD product. The way it works is simple. Click on the tool, click on the scene, you get a heads-up display as you draw, click to finish. You can then change the properties of the drawn object. On the left panel, there are a number of grips that allow you to move it, rotate, extend, and many more options. So let's go through some of those options because these options are the same for all drawing objects. So I can convert to any of these 3D shapes. So if I wanted to convert to a guardrail, immediately I have a guardrail. And when I get a guardrail, the properties then are relative to the guardrail, no longer a line. So you can change the type of beam, the position on the beam, the posts. All of those things can be changed in real time, right on the scene. Let's go back and try another one. So perhaps a 3D guardrail. Same thing, when I click on it, its properties are relative to the guardrail, the concrete guardrail. Let's try another one, a brick wall. All of this from something that originally started as a line. And of course it is truly three-dimensional. I can extend one end three-dimensionally. So you have all these controls for each of the drawing shapes. Let's try the three-point arc. Click, click, and now we have an arc. And notice the radius, core to middle ordinate information updating on the left. So now we can show you one of the other really neat features of all of our drawing tools is I can right-click, add parallel. So if I knew the other side of the road was 7.2 meters away, there it is. And now we can demonstrate another feature of the software. We extend the edge of the roadway upward, use the surfacing tool, select one edge, and then the other. We now have a surface in between. The surface can be any type of texture that you want. So if it was a brick roadway, there it is. Now it's a brick road. It goes without saying, any vehicle that's placed on that surface automatically finds the surface precisely. Back to the drawing tools, polycurve, click, 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 right click to finish. Now I have total control of every vertex. You can add more, you can control the elevation of each of them, and each of these of course can be converted to any type of shape, like a curb for instance. Now we have a very specific curb. You need to adjust it. Well, we can go in and choose and control all of the vertices of that 3D shape. That's a quick overview of the drawing shapes. Download from survey instruments. Measurements, we can put in coordinates, triangulation measurements, or download for any type of survey equipment. So any type of survey equipment that you might have or external data collector is supported directly. Here's how it works. Choose your file or total station. choose your file on the data collector, connect the points, import. Instantly, we have a scene. How do we edit the scene? Very simple. Click on any of the drawing shapes, and we can change the thickness to any value you want. You can work in 2D or in 3D. Click on the object, change its properties, convert it to a 3D shape, whatever you want to do. Very, very simple. Click on the shape, right-click, surface. All of those things are very, very easy to do, and everything prints as a CAD object. This is a crash scene, a real crash scene, a fatal accident in Pasadena, California. So, what are some of the things that we could do with this scene? One of the things that we could do is a momentum analysis. So looking at the scene and the way the roadway marks are, we can see that there was 2 vehicles in collision right here. Now I'm going to click on one of the points, bring up my measurement set, and I'm going to reduce the size of the points because they're too big. If I want, I can also change and look at the descriptions beside each point. I can choose what I see. In this case, I'll just turn it back to numbers. Go to Analysis, Momentum. Now with our momentum system, we can make a determination of the speeds of the cars right on the diagram. So we're just going to manipulate the conservation of momentum system right on our scene. We'll go to Vehicles, choose the vehicles. Now the actual vehicle was a 2004 Acura RSX. That's one. The other was a Mini, so we'll go straight to Mini. 2005 Cooper. Now we have the actual vehicles on the scene. We can adjust them to their impact configurations, rotate them to their correct rest positions, line them up on their wheels. Now I'm going to change our background texture right now to asphalt. Notice how the road lines are shown. So this vehicle actually rotated like this to its rest position, and we're going to manipulate until our marks actually line up. So we're going to move and rotate until we get an agreement between the marks on the road and the actual simulated tire lines of both vehicles. And look, we have the speeds now, 47 and 54 in whatever units you want to look at. Right away we can just hit play and animate at the speeds that the momentum analysis just determined. Very simple. How do we prove it to the court? Click on it, go to the report, and now you'll see in the report all the details. Your logo, Health Sciences Authority is in place. You can edit the header right here. All the details to support the findings are in place. So this is a very long report. I'm not going to go through all of it, just to show that this 20-page report will show everything. One more advanced feature is SAMI. That is, we can simulate the damage. Now the program will actually simulate the damage to the vehicles to comparison to the real world. This is an excellent feature. So there it is. momentum. That's one kind of momentum. Let's do another kind. And again, I'm going to put a texture just to make the scene easier to look at. Collinear momentum works exactly the same way. This is an excellent analytical procedure if the vehicles were in a collinear configuration. We do the same thing. We choose the vehicles from the database, so you're working with the exact vehicles that were involved. All we have to do is tell the system something. Tell them the speed of 1, the speed of 2, or the relative speeds. The tire road information is automatically captured by adjusting the vectors. Under knowns, let's say we know vehicle 2 was doing 5 miles an hour. That means our speeds are 72 and 5. We can do the same thing. On damage, we can simulate the damage, which in this case is extreme. Just as easily, we can convert this into the other configuration that's possible head-on. Same thing again, the program automatically simulates the damage, calculates the speeds of the one vehicle that we did not know the speed of. Same thing, you're going to get a very detailed report. Now let's do another type of roadway configuration or calculation tool, simulation. So to do that, we'll take vehicles from the database. Let's use something entirely different now, BMW. And we're going to put it into motion to start the simulation while the vehicle's in motion. And we'll get another vehicle. 27,000 different vehicles in the database. Notice how easy it is to set up the simulation. All we do is put the speeds in. 55 for one, that's what we're going to try, and 45 for the other. Add to simulation. Click on this one. Add to simulation. It immediately configures and determines the outcome. It simulates damage and trajectories at the same time. To update it, you can change it. Even in the smallest amount, will automatically change the simulation or change the speed. Every time we change the speed, it recalculates. This immediately becomes a 3D animation that you can record. Simulation, because of the nature of simulation, it can be in whatever configuration you want. If we want to move this and now we've got a head-on collision. So it doesn't matter what sort of configuration you use, the program will simulate it in real time. Google Maps are an option. in the program for a way of starting the scene. We could type in a location, and immediately get the roadways. And if you want, put the map into the system. Immediately, any vehicle that goes on the scene is on the scene exactly the right size. So the Google map can actually be used as part of your scene. Now we're going to demonstrate the tractor-trailer capability. So again, I'll put a texture in the background. Go into the tractor units, choose this tractor. We also have buses, etc. We'll use a trailer. So there are all different trailers that you can use. Of various configurations. Now what we can do is join the two together. Click on the tractor, hold down the Shift key, click on the trailer, articulate models. Now you can form or adjust to the common point of articulation and the common point of turning. Now this is an articulated model. So watch what happens when I add an animation path. It automatically shows the sweep path. And we'll slow down the animation. And the vehicle will properly articulate. That's articulation. In this case here, we're showing a scene that has been constructed with measurements, a Google Earth picture in the background, and shows the capability of the lights. So each vehicle, up to 500 vehicles, can have headlights being displayed in the scene. These are the advanced animation capabilities of FARO Reality. Now we're going to show what can happen when you're using terrain. So in this case here, we'll load a Google map and use Google terrain, but you could use terrain from survey data or whatever you like. Now when we download the road, we can click on it and also download the 3D terrain from Google. Now we have a proper terrain map from Google. This also could be from total station points. And then any vehicle that's on the scene, if in animation, will automatically follow the terrain. And if we want the vehicle to roll over as it follows terrain, that is no problem. We can use the rollover grip to demonstrate the rollover in either direction. The vehicle will automatically adhere to the terrain surface. When we hit play, it follows the surface correctly. No matter where it comes to rest. One quick adjustment. The path will then find the surface again and be corrected. For crush, you're always going to use a vehicle from the database. Click damage. Now we can choose which vehicle or which part of the vehicle is damaged. Say for instance it's the rear. We will enter the crush in centimeters. Crush depths in centimeters. And when we click preview, we immediately see the crush three-dimensionally for the damage profile. When we click crush analysis, we get the calculation. Because we did a calculation, we'll immediately get a crush report. Crush is very, very easy.